In this video, I will derive the kinematic equations via the sheet that was handed out in class. So let's first start by recognizing, just to reiterate, these kinematic equations are a set of equations that can be used to solve problems of motion when there is constant acceleration. There must be constant acceleration. So if we have a problem that there's not constant acceleration, we either can't solve it or we need to use a different method. So as was shown on the sheet, we've got the various variables that we'll be using and the two initial equations that we started with. Hopefully, at this point, you have tried to work through the problems. If you haven't, you should pause this video and try this on your own first before watching the video. So let's first start with the equation that we're going to derive the first kinematic equation. The first problem is that Dr. Perry is initially jogging at 2 meters per second. He accelerates at a rate of 3 meters per second squared for 2 seconds. What is his final velocity? So we start out by just writing down the given information. Initial velocity 2 meters per second, acceleration 3 meters per second squared, and the time is 2 seconds. Finally, we're writing down what we're looking for, the final velocity. Now, if we just think about the basic idea of acceleration, we can figure out that his initial speed is 2 meters per second. The idea with acceleration is that he is accelerating, he's gaining velocity at a rate of 3 meters per second every second that passes. He does this for 2 seconds. So after the first second, he'd be going 5 meters per second. After the second second, he'd be going 8 meters per second. We can also think about our equation for the average velocity is equal to the final velocity minus the initial velocity over time. In this case, since we are talking about an constant acceleration, we no longer need to have this average thing here, and we can just write that the acceleration is equal to the final velocity minus the initial velocity divided by time. Now, since we're trying to solve for the final velocity, we can actually do this before plugging in numbers at all. So we multiply by t, we get AT equals V final minus V initial, and then we can add the velocity to the other side. So in the end, we get V final equals V initial plus A times T. So if we look at this problem, we now can say my initial velocity is 2 meters per second. I add on my change in velocity, which I find by multiplying 3 meters per second squared times the 2 seconds. And I get 2 meters per second plus this 6 meters per second. That's how much my velocity changed. And I get a total of 8 meters per second. And if we go down here, this problem asks us to write the general equation. And we actually already have, by the process of trying to rewrite the A equals change in velocity over time. So our final velocity, or sorry, my final equation for the final velocity, that sounds very funny, but we'll go with it anyway. The final velocity is equal to the initial velocity plus A times T. This is the first of our kinematic equations.